Thank you, Stephen. Absolutely happy to share how this all works. Of course, as Jessica said, operational databases are solving a critical sort of real-time use case for customers. What becomes important in this case is to take all these events that are happening across different systems and bring that into the operational database. And that means the ability to have real-time connectors that can take the data, stream that into these systems, and requires a data architecture that can support this sort of a use case. Um, so let me talk a little bit more about that in the context of Nexla. And to introduce myself, I'm Saket, co-founder and CEO of Nexla. And what Nexla does is it brings automation into data engineering as a practice that is becoming increasingly in demand to serve the needs of growing demands on use of data across different business functions. So to chat a little bit about that particular need in the industry, let me share with you some of the challenges that companies or teams are facing today. When we look at the middle part of this diagram, we see a sort of an inverted pyramid. At the bottom of the pyramid are data engineers and infrastructure teams that are supporting an increasing number of users of data. And that user of data and their demands are actually growing very rapidly. If anything, in the past year, with generative AI coming to the forefront, this demand has increased even further with an even greater variety of data now needing to bring in unstructured and document data into the flows. The way this inverted pyramid finally stabilizes is two factors. On the left, we look at the automation that can help these teams. And automation comes in form of many different capabilities with things such as automatically generating connectors to new systems, automatically modeling the data in many cases, and automatically figuring the scale. What also comes along that helps teams to scale is the collaboration part. And the collaboration is about people who are experts in data and understanding of data to work with people who are experts in data systems. And that comes with no code, low code, and even pro code capabilities. And all of that coming together is what brings scale and reliability into how the data function works. And now you can build your applications and scale on them. To go further and talk about how this all works, let me switch to the next slide. To talk about that, when modernizing, we need to think across various data management tasks, including data integration, data discovery, data preparation, cataloging, and governance. And it starts with capturing metadata and applying machine learning to metadata and then enabling automation with that. So that becomes a core part, and taking that metadata into our architectural approach is an essential part to becoming capable of supporting those increasing demands that come to the data teams. Now, for those who are familiar with data fabric or data mesh approaches, metadata serves as the connecting glue for both these approaches. Applying intelligence to metadata is the core enabler of data fabric, and metadata is also a key ingredient in generating data products that data consumers can trust and can use. So I'm going to go a little bit deeper into what does it mean when we talk about metadata, and to understand that metadata actually comes in many forms and shapes. So here we take a look at something very simple. You have, let's say, a spreadsheet, and in a spreadsheet you have first name, last name, email ID, for example. What is the metadata associated here is something like what is the schema, which you can infer, for example, very easily. In this case, how many records are coming in? What is the timestamp? When is this coming in? What is the name of the file? If we process the data, how long does it take, and so on. On the right-hand side, we look at how might this metadata change over time. So let's say now we also have phone number that is coming in. So now the fact that the schema got updated, how many records are getting processed now, and what are the changes also in characteristics of data. So as we go deeper, you will see that metadata actually comes in many forms and flavors all throughout the data processing. And here's a quick example of how you might want to understand and perceive metadata. For example, a change in schema could lead to even further information like when did that happen and what is the version associated with that. So going further a little bit into the metadata aspect, it is also important to see that metadata actually can be generated in many parts of the data processing cycle. So for example, a data connector itself can capture metadata, for example, from a database as a schema. And in addition to that, metadata also gets continuously generated. We consider this as active metadata throughout the process of working with data. And this type of information can be further used to tune how we work with data. So let's take a quick sort of view of different ways in which metadata can generate capabilities that may not have been possible before. So if you think about data credentials and rate limits and API documentation, using that information, for example, allows us at Nexla to help generate connectors and connector configurations more easily. Looking at data samples, the schema, logic helps us produce data product entities. Understanding the data characteristics helps us monitor the data better and automatically. And pipeline instrumentation allows us to bring in auto scaling. And we'll look at an example for that as well. Let's look at, what are some of the practical benefits of using this metadata-driven architecture. So one of the benefits that we see is on the left-hand side, we have been used to building or using different type of data integration tools because of variations in data. Where does the data come from? Where does the data go to? What velocity is data to be processed? And for each of those, we are used to a separate tool, like an ETL tool or an ELT tool or a streaming tool or a reverse ETL tool, and so on. Now that has created a mechanism where you have a whole bunch of point tools to work with. What happens when we start to leverage metadata? For example, what we do at Nexla today is the understanding of data that we build as we learn the data and its structure, we end up creating these virtual or logical data products. And these data products become sort of an anchor entity, which give a unified representation to data. So as a data user, you don't have to worry about whether the data started as stream or an API or a file or an event. You work with the same consistent data object representation that you're used to. And now that data object can be connected to deliver data into all sorts of different places. Now, separating this design from the execution means that depending on where the data is coming from and where it's going to, our system is able to run either batch, streaming, or real time. So what we are doing here in a nutshell, and it's a lot of detail to get into, which I'll skip, is that by being a metadata first architecture, we're able to converge different types of data integration patterns into one tool that is simpler for people to understand and work with and collaborate around. So let's take another example, a little bit more specific to a customer case. And here I want to talk about one of our customers, which is actually a top marketing and advertising data platform. So in this case, what happens is that the company works with user lists, and those user lists, for example, are matched to different audience segments, and as process of that become targetable entities in different ad platforms. So in this case, data is being read from, let's say, some files or APIs. It goes through a certain amount of processing, for example, and then can push into different platforms. Now, different platforms will need data in different ways. For example, Facebook takes an API, and a trade desk would take a file, and so on. So the ability to now run all of this at scale across billions of devices and users is very critical to business execution, because you're taking those few billion records and pushing them across multiple platforms. So let's take a look at how metadata plays a role in making this scalable. So when users come into our product interface, for example, they're able to choose how much velocity do I want, or how much resource do I want to maximum allocate to run this particular pipeline. So you completely visually design that and give a hint to the system that my goal is to get it done, let's say, in half a day, and it would otherwise take 2 days to run that. So I'm going to give a hint that run it at 4x or 8x speed. When we do that, the underlying metadata about how much time is it taking to ingest or transform or process or write, or what is the rate limit of that API we're pushing the data into, and how to handle that rate limit. All of that information sort of comes together into the execution engine in such a way that the system can start to dynamically scale. And in a very quick visual on the bottom left side, you will see that the number of containers, for example, that are being allocated to reading data are increasing as the system figures out that the consuming system can handle a higher rate limit, and then keep pushing the boundaries until it sees that this is the maximum throughput it can do, and that's the max performance it can get. And in process, it may be generating or processing multiple streams. So when we take a look at the real outcomes that come with that, in real world, what we have seen, for example, in this particular case, is something that took 36 hours and sometimes even more than that into 2 to 3 days became a 17-hour process that is being designed in a very simple way. That metadata architecture, that abstracted data representation became easier for people to use, but then the leveraging of metadata to run and actually do the data engineering and the data processing meant that they can very easily increase the velocity of execution up to the maximum limit that the end systems can handle. So with that, I will wrap up and just share that taking a different approach to architecture can help systems be more modern and more scalable and more flexible overall. Thank you.
Thank you very much, Saket. I have a question for you. If you're making it easier for people to work with data, what are the security and governance implications?
Yeah, those are huge. I mean, we have talked about democratization of data, but democratization had been discussed without a governance framework. And what we are talking about in collaboration, in one of the key pillars of making your data processing scalable, is one where people can work together. So when we bring governance into this play, and when we talk about these abstracted data objects that can be collaborated around, I think governance becomes extremely important. And so, yes, we do want data usage to become easier because that creates business value, but at the same time, absolutely essential to have governance.
As the volumes of both structured and unstructured data continue to grow, what are the key approaches to address the challenges of scalability and flexibility?
You have to pick the right tools. And with the increasing sort of variety of data, the tools that can handle more variety do give you a lot more flexibility. And it's not just about processing and running the data in some of the use cases, it's also being able to orchestrate and manage many such complex flows and operational requirements.
The next question is, and Saket, we're going to start with you. What kind of effort is required to move from a traditional data architecture to a modern data architecture?
Yeah, in many companies, things are already running on an architecture. What we are seeing in typically is that the number of net new use cases coming are happening at a very high rate. And what is the easiest path for people to modernize is to take those new use cases and to bring them up to a more modern architecture. Because if you're solving 100 problems today, you're probably looking at solving 1,000 problems in the next 2 years. And over time, you can bring older stuff also into a more modern flow. Yeah.
Data products have become a popular topic in 2024. How do data products play a crucial role in modern data architecture? And what are some best practices you can share for succeeding in the real world?
Yeah, I'll probably take a small sliver of that answer because I think some of my panelists are closer to this. But data products essentially mean sharing of data, and that means it brings its own set of risks in terms of have I shared the right data, whom have I shared it with, how is it being used, have I leaked things that I should not be leaking, which are classic security and security governance questions, and those are some of the reasons why customers again start hitting the roadblocks when they try and do some of these, push some of these initiatives. They get pushback from the security team, which says, "Hey, we have no clue what's going to happen. Can you give us the visibility? Can you give us the reporting?" And until then, we can't sign off, right? And so that's where we tend to, get pulled in very often.
Understood. Saket, how about you?
Yeah, so data products are bringing a framework where we think about two entities: the one that produces the data and makes it, usable, and the other that uses it. And this sort of decoupling allows for much greater scale and collaboration across teams because now both of these entities are not tightly connected and doing a lot of back and forth. And the approach of data products, in the way at least we approach that, is that they also give a consistent interface to data independent of the source system. And they also allow you to deliver data to different places independent of the target system. And that allows for convergence of tooling where the same sort of interface and tool can now deal with a lot more variety of data processing than could have been done before in more one-to-one or point-to-point architectures.
How can organizations ensure their data architecture remains adaptable when it comes to supporting Gen AI applications? Hot topic, obviously.
Yeah, I think the way to think about generative AI is that in the traditional data architecture, today's architecture, when we put the same query to the system, it comes back with the same answer. But in a generative AI world, you ask the same question three times and you get three different variants of the answer, all looking very right. So for the enterprise, then it becomes a very different challenge to get consistency and reliability. And how that works is you got to be able to work with embeddings and vector databases and use unstructured data. So you need that part in your data architecture. You need to still work with structured data, as Sean was saying. Bring in that real-time context. What was this person looking for to travel to, for example, if it's a travel related question. And then also take advantage of the fact that you have to orchestrate many of these. Which model am I going to use for what kind of question, and how is all of this stitching together? So it puts a new type of requirement on, I think, the traditional data architectures that are out there, and the way organizations can remain adaptable or bring to that is, again, look at foundationally tools that are more flexible, tools that are not tied to one sort of a paradigm. And I think, and I'll go back to what I said earlier, is these are tools that are using metadata and being more adaptable rather than relying on pre-programmed sort of frameworks.
Understood. So we're past the top of the hour, but everyone has stayed with us past the bell. We appreciate that. But I think we're going to wrap this up with one more question. It's something I always like to do to offer all of our speakers a chance to kind of provide final remarks. So one last question. If there's one thing you'd really like our attendees today to walk away keeping in mind, what would that be?
Yeah, I think the one takeaway I would say is that your needs are going to only grow faster than you can imagine. And as Jessica said, it's very important to have that sort of framework when you're approaching these as architecturally what is designed to take me further and longer. And I would say that definitely there are many new sort of approaches that have come up and been looked at that can deliver that need for you.